All right, welcome to podcast 4.3, and this is on molarity. And what molarity is just how many moles of solute per volume of solution in liters. And probably an easier way to think of it is what is the concentration? The concentration. All right, so you saw last year a whole bunch of different numbers next to solutions with a big M, just like this big M right here. And all that told you really was how many moles of solute, and that's the stuff you dissolve, in how many liters of solution. So if you had a 2 molar solution, that would mean 2 moles of solute in a 1 liter solution. So if I had a 2M, and you saw something like NaOH, all right, if you saw that, that would mean 2 moles of sodium hydroxide in 1 liter of solution. Well, let's look at a typical problem that we'll see here. Calculate the molarity of a solution with 11.5 grams of sodium hydroxide dissolved in 1.5 liters of solution. So, we've got to find some moles. It's right there, right? Good thing we're good at it. So, 11.5 grams of NaOH. And let's see, 1 mole of that stuff weighs 40.0 grams, and that gives me a value of 0.2875 moles. Okay, so we've got the mole part done. Now we've got to take care of this liter part, right? So let's divide by the liters they've given us, which happens to be 1.50 liters, and there we have it. We get a value of 0.192 molar. Okay, so that is the concentration of our solution. Not too bad, right? Well, let's look at another problem. Okay. How many grams of sodium hydroxide would be required to make 250 mils of solution? All right, so when looking at a problem like this, you just want to remember that molarity is simply moles per liter. Okay, so I'm just going to take, I've got to figure out how many grams, right? And in order to find grams, I've got to find some moles. So how could I find that knowing some volume and some concentration? Well, I'm just going to take my 0.250 liters. Okay, all I did was I moved the decimal over here, right, to make it liters. So my units cancel, and then I'm going to go 0.400 moles over 1 liter, right? Again, the whole cross-canceling thing. You guys remember that ad nauseum from last year. Okay, and then what that gives me is 0.1 moles. All right, and if I don't know moles, then I've got 1 mole of sodium hydroxide weighs 40 grams, and that's going to equal 4.00 grams. Okay, pretty simple problem. Okay, so let's look at the next one. We're rolling right along here. I don't want to take the time to do this problem, but I want to talk about this second bullet because it is super important, this bullet right here. Okay, but if if you want to pause the video and try that problem, it probably wouldn't be a bad thing to do, but you're going to get an answer of 0.487 molar. Okay, but the question is what's the concentration of each ion? And that is super important because you have to remember that when calcium and chloride get broke into water and they get hydrated, they break up into this, calcium 2 plus and 2 chlorides, right? So the answer is, what's the concentration of each ion? Well, for calcium it's 0.487 moles, but for the chloride, it would be 0.973 molar. Okay? Again, all that number is twice that, right? Because there's 2 calcium ions for every 1 calcium chloride. This is a super, super important concept. It's all back to the mole ratio thing, and I can't tell you how many times this thing right here just gets brought into play, where they're asking all the time about that. So you've got to really pay attention to that. All right, let's look at another problem. Oh, those are the answers. Let's move on here. On to making solutions. Describe how to make a 100 milliliter solution of 0.1 molar. All right. Well, if I was going to do that, now it kind of sounds odd they're asking you to describe that, but really the reason they're doing that is because you'll get some lab questions. But let's just go ahead and find some moles, right? So how many moles would I need? Well, I would need 0.100 liters, right, times 1 mole per 1 liter, and that equals 0.1 moles. So I need 0.1 moles of that beast right there. And let's see, what does that weigh? That happens to weigh 294.3 grams per 1 mole. Okay, and so you'd figure out it's gonna be 29.4 grams of stuff. So you would take that 29.4 grams of potassium dichromate and you dump it in 100 milliliters. Okay. So again, there's another bullet here. We don't need to do this problem. As a matter of fact, I'll probably give it to you tomorrow for a startup question. But it's basically the same thing. You got to think about moles and think about volume, and you can do all these problems. On to the next one, dilution. Okay. Now, when you have a solution and you need to dilute it, basically you're just going to be adding more of the solvent. For us, it's always going to be adding more water, and so we're going to use a very simple formula. The formula here is M1 times V1 equals M2 times V2. And you've got to have the same number of moles. Whatever moles you had before, you're going to have that amount after. However, because you've added a new volume, you're going to have a new concentration, and that is what molarity is. So the stock solutions are what I have in the back room, and all the solutions you guys use are ones that are usually more dilute, because I can take a stock solution that's 16 molar and I can dilute it down to, let's say, 1 molar, and that's a lot easier way to do it. So let's try a problem. What volume of 1.7 molar solution is needed to make 250 mils of 0.5 molar? Okay, so again, the formula we're using is M1V1 equals M2V2. Okay, now I'm going to use the 250. I'm not going to switch this to liters. I mean, we could, but that's just doing more work because I'm going to get an answer in milliliters, and I want an answer in milliliters. So I'm going to go like this: 250 milliliters times 0.5 molar equals 1.7 molar times V2, right? Now when I solve for V2, and you guys could definitely and should definitely check my math, I get 73.5 milliliters. All right. If you convert it to liters and you got 0.073 liters and you gave me your answer, that would be perfectly fine. So what I want you to do right now is pause the video and try this bullet right here and see if you get the right answer. All right. So if you did that problem, hopefully you got this answer right here, 0.185. And if you didn't, it is definitely the first thing we'll do tomorrow when we talk about this problem. So anyways, if you have questions, again, ask me the next day, and hopefully it worked out okay. Thanks, dog.